Hello everyone, I am Vishwamohan and I am very excited to start the day one of 5 days of low level design challenge. So friends, if I am talking about the low level design, this topic can't be done unless until we all are mastering two concepts. One is called as design principle and another is called as design pattern. So before we get started and start our journey, let's keep our concepts clear and have a very crystal understanding that what is design principle and what is design pattern. So if you're going to talk about the design principles, it's more of like giving gyan. Normally you would have seen elderly people, the saints, right? They normally tell you that what are the right ways to lead your life. Design principle is very much similar to that. So our experienced software developers, the people who have worked on so many software developments, they typically based on their experience has given you certain suggestions that when you are building an application, follow these guidelines. If you do that, the chances are that you will be able to write the scalable code, you don't have to maintain it much, modifications might be easier. A very much example of that which is very relevant in today's world is solid design principles, where you are suggested that these are the principles that you should follow when you are building an application. On the other hand, design patterns are more of like a practical implementation. What that means is, these are the actual code or the actual implementation which the people have found when they were actually writing the code. So the design patterns are the actual implementations. Now for we as a modern engineers, if we are trying to build the modern applications, a good understanding of design patterns and design principle both goes a long way in making us a better software developer. So in this video, I'll ensure that we master the first part, which is design principle, and we would like to master the solid design principle. One of the topic which is super important, not only for making you a perfect developer, but also for cracking the interview. This is one of the most favorite topic or the concepts to be asked in the system design now. But let's try to make this interesting. So unlike all the other places where typically when you start learning solid design principle, you're told what is S, what is O, what is L. I'll not take that route. Let's take an interesting problem statement, write the code for it, and we'll see that how solid design principle could be involved, could be used. So let's get started. So now let's try to jump directly to the problem statement. So the problem statement says that we are trying to build a library system. We have to build a library system, and this library has library items such as books, CDs and DVDs. So the first line is telling me is that I have to go and create a library system. And in this library system, we have something called as a library items. And what are the subtypes of the library item? The subtypes of the library items are books, CDs, DVDs. Right? This is the current set of the items that I have that I want to go and keep in the library. Very nice. Now each item has a title, has a unique identifier and a type specific property. Okay. For example, each book will have an author. Fair enough. The system should allow users to check out items. These are the functionalities that I expect from the system. The system should allow user to check out items. Calculate the late fees, because in the library you are expected to take the books on the rent, and if you don't return on time, you have to pay some additional fees, right? Based on the item type, and determine the total value of all items in the library. So these are the functionalities. These are the functionalities. Now, let's see to understand what we want to achieve as a part of the video, right? So as a part of this video, I would like to achieve that this design principle that I have been talking, design principle, right, which is solid design principle. This is one of the most importantly asked concept. This is the most important asked concept in the interview these days. So each word, solid is basically an acronym where each word, S stands for single responsibility, right? O stands for open close. L stands for the Liskov's substitution principle. right? I stands for the interface segregation, right? And D stands for the dependency inversion, right? These are the acronyms. So instead of directly understanding, bhaiya, what is S, what is O, what is L, what is I, and what is D, what I'm going to do is that we'll try to solve this problem statement and then see that in this problem statement how I'm making use of all the recommendations of the solid design principle. I'm again repeating, I'm trying to make a library system. The library basically contains the library items, which contains the items like books, CDs, and DVDs. Fair enough. And then each of these will have some kind of identifier. What are the functionalities? I should be able to check out items, that's number one. I should be able to calculate the late fees for each of these type, right? And I should also be able to know that in library what is the total values of the item. I have to go and convert this into the code. So now we have understood the problem. Let's try to write the code and see that how we can make use of the solid principles to solve this problem elegantly. I would expect you people, if you can write the code with me, that will be great. What you can also do is that pause the video now, try to solve this small problem yourself, and then once you are done, please compare if your solution was similar to mine or how much was it related to the solution that I am going to provide now. Let's get started. So every time you get a problem, it's not a good practice that you directly jump and start writing the code in the editor itself. So what do you need to do? Initially, we should do some kind of planning that how do we start? What does the problem say? What is the future scope? See, the good developer is the one who does not only try to solve the problem in hand, but also see that how the same system could be extendable in the future itself. So let me go and clean this up. What I see is that right now, if I go and talk about the library item, right now I have three, right? I have books, I have CDs, and I have DVDs. And each of them had some common attributes which is being mentioned, like each will have a title, each will have a unique identifier, each will have a type specific property. So what I can do is that each of these books, CDs, and DVDs are of the same type, which is the library item. So what does that mean? It means that it is a good use case that if I can go and create some common library item as an interface, and these could be the classes that I go and define. Does it make sense to you guys? And this also gives me a flexibility that in the future, let's say that I want to add few more additional library items, say for example magazines or newspapers. I can typically do because they can also implement that the same interface. Right, so for this I'll need to create the interface and then the concrete classes for as an implementation. Secondly, I'm saying that I should be able to calculate the late fees. So for calculating the late fees, each of these concurrent books, for example, this each of this library item, it will be a feature of a library item, right? For example, CD might have a different rate, DVD might have a different rate, books might have a different rate. For each of them, should know how the fees has to be deducted. So when I'm writing the code, I have to ensure that each library item should have some method through which I can go and calculate the late fees, right? And then for calculating the late fees, let's say that a user takes multiple items, right? And I have to go and calculate the fees. So there should be a dedicated class called as a late fee calculator, who is responsible for doing this. Fair enough. And then I should be also able to total values of all the items in the library. So typically, if I have the library class, this should do all these functionalities. So high level planning I have done. I know what interfaces that I have to go and build. I know what classes I have to build to implement all this feature. So let's get started. We have done a very simple setup. The setup that I'm going to make use of that in the term of IDE, I'm going to make use of IntelliJ. You people are free to use ID of your choice. If you want to use IntelliJ, great. Otherwise, if you want to use Eclipse or code or anything else, I believe you should be comfortable using it. There's nothing worries, because I'm going to make use of the core Java. I'm going to make use of core Java without any external dependency to complete the project. So let's start the IDE and get going with the coding. Hello everyone, as you can see that my IntelliJ is ready on the screen, and I have created a new project called as the day1_ld. Okay? So this is how I've created a new project. So very first thing that I'll do is that this is the default main file. Let me go and delete this file because I don't need it. So let me go and delete this file, delete. And this is SRC folder. We'll be going to create a folder called as items. We saw that we have already seen that that we wanted to create the different types of the library items, right? So as we discuss, we'll try to, first of all, what we'll do is we'll try to create a library item as a interface, right? And then what we'll do is that this library item, the childs will be most of, like, for example, books, for example, CD, for example, DVD, right? All of these will be like the childs of the library item. And the library item should have, now, if I go back to the problem statement, the library item should have the title, unique identifier, right? All these kind of things it should have. So let me go and add that. So if I come back here, let me delete this. Let me go and define an interface, and let me go and call that as library item. ठीक है, तो हमने library item इसमें बना दिया, and this library item should have some methods like string get title, right? I can go and say that string get unique ID, and then string calculate late fee days, double get value. So this is an interface. What I have done is that, as one of the requirement was to calculate the fees. Now every library item will know itself that at what rate the late fees has to be calculated. So I have defined this as a part of this interface itself, and then these unique things, like, because I know that every item will have an item, so every item will have a title. So I have the get title method, I have a get unique ID method, and I have to get the value of that item, right? So these all things I have made as a default. So once I have done this library item, if you see here, this library item is only containing the information about only the information about the item. Okay? It is just containing, in other words, if I go and talk, it just contains single information, right? If I look into this library item, मैं देखना चाहता हूँ, तो what I'll see that it is doing only one thing. It contains only, the only thing that it is caring about is the library item. What is title, what is its unique ID, how to calculate the late fees, how to get the value, but everything is centered around the single thing itself. Since in this interface, we are doing only one thing, that's what the first principle of solid says, which says that solid design principle, S says that it should be the single responsibility principle. This is one of the most basic concepts. A single responsibility principle. SRP says that, sir, that whether you are creating an interface or you are creating a class, ensure that then one class or one interface is only taking single responsibility. If you are able to do that, you will be able to write the clean code. So as you see here, this library item is doing only one thing. So this is following a single responsibility principle. So this is an example of this interface is following a single responsibility principle. This is a single responsibility principle. Now one of you may ask me, sir, what is the importance? Why is it is needed to do a single responsibility principle? It is important because only when you're trying to do one thing, you can do it more efficiently. Let me take an example. Let's say that you go to a Domino's store, and let's assume that the person who is taking the order is not only taking the order but also is baking pizza. What will happen in that case? He will take the order, then he will jump to make the pizza, bake it, and then return back. Now this whole process will take a lot of time, right? And because of which there will be a long queue of the customers waiting, because once I have taken an order, I have to first go and bake the pizza, which takes some time. That's one. Number two, let's assume that while I'm baking the pizza, I hurt myself. So now no new orders will be taken. Correct. On the other hand, if I ensure that there are dedicated people doing the dedicated work, let's say that if I am at the counter, I'm only taking the orders. On the other end, there's a dedicated person who's only doing the pizza making, who's baking the pizza. In that case, when everyone is doing their dedicated job, it could be done more efficiently and it could be done more faster. And that's the importance of single responsibility principle. That says that when you are building application, when you're writing code, ensure that one class, one interface that you have written is doing just one single thing. And that's what we are doing here. So it is an example of single responsibility principle. Fair enough. So I go and rub this up. Once we have defined this library item, now it's the time to go and define the other items that we have in the library, the more concrete implementation. So I go and do what is that? I go and define a class, and let me go and call this class as books. So now what I have to do is that I have to go and open the book.java. I can give the name is that. Now book, since it will have to go and implement a library item, very nice. Since it's library item, so I have to go and implement all these things. So I have to go and get this done. Fair enough. We'll fill this code. So what I've done, I have written the book. It is implementing the library item, and then I have to go and implement all these: get title, get Unix ID, get calculate fees, all of that. Now for this, let me go and define the features. For example, I have something called as private string title. I have a field called as a private string unique ID. I have a private string author, private double value. Right? Title, unique ID, author, and the value. Now for all of these, I can go and define a constructor. So I go and define constructor like this. So I go and define the constructor. So I have this book class which implements a library item. These are the field title, unique ID, author, value. I go and define the constructor, and I go and define all these methods. Now if I have to go and return the title, what I can do? So I can go and say that return this dot title, return this dot unique ID, calculate late fees. Now for calculating the late fees, what I can do is that I can go and say the return days into, let's say that for the book it is 10 rupees per day. So if I go and multiply this, then this. Now late fees should be not string, no? So the late fees should be, say for example, it should be int. So it should be int. So I got the days into the 10, and then get value is equal to return this dot value. Fair enough. So we define this book class. Similar to this book, we might also have to define the other classes like CD class and the others. Right, so let me go and write that Java class, and I'm going to call it the CD. Right, CD implements library item, and then I go and we have to go and implement this methods, and then it will have again string title, and it will have public string unique ID, similar to the previous one, and I have the private double value. I can also have, for example, city, then I can have the artist, private string artist. Fair enough. And then I can have the constructor, which will have all these values. Title, I can go and return this dot title. Unique ID, I can go and return this dot unique ID. Calculate late fees, it could be, say, for example, days, and let's say that instead of 10, now I am charging rupees 20 here, and this dot get value. Fair enough. So this is how I'm going to find this CD, and similarly I have to go and do for the DVD also. So I'm going to find a class called as DVD, right? This DVD, I can just copy this fields here, and the DVD identifier could be, say, for example, here private string, and here also let's say that artist only, right? And then it implements library item. So I need to go and get this, and I have to go and return this dot title, this dot unique ID, turn days into 30. Let's say that it's the price of rupees 30 for the DVD per day, and the value should be this dot value. Awesome. So I have written all of these. Now if you need to look at each of these implementation, be it books, be it CD, be it DVD, you see a pattern. The pattern is that, all these classes, the books has been inherited from something called as a library item. And any changes, let's say that if I want to go and do in book, which is basically a child or an extension of this library item, that's not going to impact the library item, right? Let's say that in the future, apart from the book, CD, DVD, if I want to have more library item, let's say for example magazine also, that's not going to go impact the original code itself. Now this has a big advantage, which is also a part of the solid design principle. In solid design principle, we have a concept called as in solid O part, it's called as an open closed principle. So this principle says that, sir, whenever you are writing any code, आप कुछ भी लिख रहे हो, you should write the code in such a way so that your project is open for extension. The project should be open for the extension, for adding more features. But at the same time, you should not do any kind of modification. It should be closed for any kind of modifications. It should be closed for any kind of modification, right? So as you can see in this case, if let's say that I want to go and implement a new type of book, or I'm going to implement a new type of library item, I'm free to do it. With this inheritance that I have brought into the picture, I can just go and define another call as, for example, let's say that I want to go and create another library item. Just like this, I want to go and create magazine. I'll just go and create a magazine class which go and implements the library item, and I'm able to do it. So the way that I have written this code, I'm flexible, I'm open to go and add more classes without impacting the existing class, which is the library item. So this code that I have written is closed for modifications, and it's open for what? Open for the extension. So we have seen two solid design principles already in this project. What were those? First, single responsibility principle. We saw that how my interface library item that I have written is doing only one thing, only single thing. So it is following a, the single responsibility principle. And the second one in this example, book, it is trying to extend the features without impacting the original one. So it provides you the facility to extend the feature, add more library items in the future if you need it, and that's kind of falls under the category of the open closed principle. I believe we are doing good in the project. We have understood these two principles. Let's code more and understand more principles accordingly. Now, when I started looking initially, and I tried to look this entire code call as a library item, I said that it is following a single responsibility principle that is trying to do a single responsibility around the library item itself. But if I try to look a little deeper, if I go and try to look a little deeper here, sir, I realize that in this library item, apart from the library item calculation, I'm trying to do something little extra. Can you guys guess out of all these things, if we have to find one odd man out method from this, what could be that? You can pause the video and tell me what will be the odd man out. It's little odd man out. That is this calculate fees. When I have added this method, this is doing slightly different than the actual responsibility of the library item is. So typically library items should only contain the title, unique ID, value. But doing additional things, calculating the late fees, feels like it's doing some additional work which should not be the responsibility of this library item. So if I want to streamline this further, if I would like that, I would go and streamline further, right? Streamline further. What I can do is that I can take this out, I can take this whole bit out in a separate interface. And you do this so that this interface becomes thin. You do this so that interface is thin. When you do this, this whole philosophy, whole policy is called as interface segregation principle. Interface segregation principle says that, sir, you should not try to make one single interface fat, or in other words, one interface should not have too many methods. If you find that interface is having too many methods, it means that it might be violating the single responsibility principles. So idea is that to break that interface into the multiple interfaces. And when you do this, that's fall under the principle called as the interface segregation principle. So what I can do is that I can take out this and define another interface here. So let me go and clean this up. So now what we do now is typically inside this items src, let me go and create a folder called as main, right? And inside this main folder, let me go and define an interface. Let me go and call this interface as late fee calculatable, and this should be of the type interface. Let's try to hit enter. Should be interface, right? And then it should have a method. Let me go and call it as double calculate fee int days. Perfect. So what I can do here is the library item. I can go and say that extends, and I can go and call it the late fee calculatable. Now as soon as I do this, now this late calculatable, right? As soon as I do this, this late calculatable that you see is an interface which has the logic for calculating. Basically, it's not the logic, but basically the method will have the method for calculating late fees, right? This late fee calculator, and this library item will have the things like get title, get unique ID, and the get value. So here what we have seen, each interface is thin. They are just trying to do one thing, and we are following this interface segregation principle. We are doing this interface segregation principle is what we are following here. Fair enough? Am I clear? Does it make sense? So now we have already seen S, we have seen O, I have seen the interface segregation principle. So as we are making more progress, we are uncovering more and more concepts of solid design principle. But if we try to look at it, it's trying to see two related problems, try to see what is happening. So inside the DVD method, we have defined this method called calculate late fees. Okay, so yeah, so the method name actually was the calculate late fees. Inside this, I have defined a method called calculate fee. So it should be the calculate late fee, right? I think this is what the name of the method is. Perfectly fine. So this works fine. So if I go now here, this looks okay. If I go to the DVD, this looks fine. If I go to the CD, this looks fine. This should be double, and the book was also double. So this looks okay. In the DVD, do we have any other error? This should not be there. Fair enough. So with this, and now if I go and talk about the book, this should be like double. So my code is working perfectly correctly now, right? And we have already seen the principles of single responsibility, we have seen the open close principle, and we have also seen the interface segregation principles. Now the next part of the code, let's get started. So in the next part of the code, what we need to do is that we have to go and do the left, the late fee calculator. I'll have to go and create. So I go and create a class called as a late fee calculator. So in the late fee calculator, what I need to do is that I need to have a logic. I need to go and write a logic to to calculate the late fees. Fair enough. So for that, I go and define a method called as public double, and I go and say that calculate total late fees. And now it might happen that when you are taking out the the items from the library, it's not only one, but there are multiple, right? And then let's say that all of those items you're returning late, so you have to find the late fees for all those items. So basically this method will take a list, right? So I can go and say that late fee calculatable. So all those items whose late fees could be calculatable. So I'm array of those items, and then I go and say that how many days late it was, right? And with that, I can go and say the double, and I go and say that total late fee. Initially, let me go and define it as 0, and then I go and say that for late fee calculatable, and I go and say that item equals to items, and then in second was the total late fee plus equals to, and I can go and say that item dot calculate fees, and in that I can go and pass the days. Fair enough. So this is how I go and define this calculate total late fees. Now if you try to see here in this case, now this is again a very important observation here. If you try to look here in this case, inside this late fee calculator and this method, right? This method takes interface instead of concrete class, right? This method takes the interface instead of a concrete class. So what I'm trying to do here, I'm trying to code for the interface. I'm coding for the abstraction. right? When you try to code for the interface, when you try to code for the abstraction, when you don't depend on the low level modules, right? You depend on the abstraction. This principle is called as the dependency inversion principle. This principle typically is called as a dependency inversion principle. Dependency inversion principle, right? So here what I'm trying to do, I'm trying to code for the interface instead of coding for the direct independency. I'm doing the dependency inversion principle. So dependency inversion principle says that you should not depend on the concrete classes. You should depend on the abstraction which I'm trying to achieve here. So it's a standard practice, sir. Whenever you're trying to write a project, you're defining a method, and that if you're trying to give the arguments, try to avoid using the concrete implementation there. Always, whenever you're one module is dependent on another module, try to depend on the abstraction rather than the concrete thing. So this is how I'm going to define the late fee calculator class. Now if I go and do this, there's some error. Let me try to see what is that error is. So what is this error? Yeah, I need to go and return this to return total late fees. So when I do this, this function is working perfectly correct, right? So I'm done with the late fee calculator, and I'm now finally done with the final library class, which will have all the final functionalities that we wanted. So now once this is done, let's finally go and define this library class, right? So I go and define this called as library class, and inside this library class, typically one of the requirement was that I would like to go and create calculate the total value of the library items. Right? So to calculate the total values of the library items, what I can do is that I can go and set a public double, and I can go and say that calculate total value, and I'll go and do like this, and I'm going to set double total value equals to 0, right? And then I will say for library item equals to, I should have the list of the items, right? Now this library should have the list of these items, right? So I need to go and define this. So I go and say that private, and then I have a library item, array of library items. I go and call it as items, right? And if I have this, then I have to go to this initialize in the form of the constructor. So I go and define a constructor here for this. Sorry, right? So I go and define this constructor, and now in this, what I can do is that total value plus equals to item dot get value, and once this is done, then I finally go and return total value. Now again in this code, I've done something very special. If you see here, if I do focus here, guys, right, inside this function calculate total values, I'm iterating over the items, iterating over library items. Now this library items could be anything, library items could be books, it could be CD, it could be DVD. So basically the parent, so what you are seeing here is that the parent can be replaced by any of its child, and in this replacement there is no risk. So if I go and replace item here by whether a CD or DVD or a book, there is no side effect, it is replaceable. So everywhere the parent object could be replaced by a child object. When you go and satisfy this kind of situation, that's typically is called as a Liskov's substitution principle. So in nutshell, Liskov Bhaiya says that you should follow inheritance only when you are pretty sure that everywhere the parent object could be replaced by any of their child object without any side effect. So here I'm pretty sure, when I go and iterate this, if this item is either book or CD or DVD or in the future any new object, it is not going to create any side effect. Every one of them will have this value. So it is following this Liskov's substitution principle. So far we have seen that with the code that we have written, this project, we are able to achieve single responsibility principle. We are able to achieve open close principle. We are able to achieve Liskov substitution principle that we have seen just now. We have seen interface segregation principle, and we have also seen the dependency inversion principle. So this project is an excellent example demonstrating all these solid principles. Many of times you student, when you learn solid, you don't understand कि भैया use कहाँ पे करेंगे इसको, how do I go and bring use solid principles. So this project, I hope, has helped you understand. This project that we have built help us understand that how those solid principles could be used in a real world project. I believe you have a good understanding today, and this first project, the day one of this low level design, had set up the right expectations. We are now clear what is the solid design principles and how effectively we can go and make use in this project. Please write this complete project yourself. Make sure that whatever that we are doing, you guys are actually doing practicals around that, and once it is done, upload over the GitHub, tag me over the LinkedIn, and let me know that you are there with me in this 5 days of low level design challenge and you are creating projects with me. I'll see you on the day 2. Thank you.